What comes to your mind when you hear the word work? Is it all of us those office works? Or the people working in a construction site? Well, actually in physics, work is defined as the transfer of energy from one body through another through the application of force which moves the body through the direction at the same force. Oh. Aha! What I did earlier was an example of work. Moving on to the next. Energy. Energy is simply the capacity to do work. There are many kinds of energy, but for this time, we just need to focus on the two, kinetic energy and potential energy. First, we have kinetic energy. Kinetic energy is the object in motion, having the formula kinetic energy equals 1/2 mv squared. Next we have is potential energy. Potential energy is the force that can be used to perform work, having the formula P is equals to mgh. And lastly, we have power. Power is simply the rate of doing work, having the formula P is equals to work over time. It is measured in watts or joules per second. This has been JVL John Villamor for Work, Energy, and Power.
Hey there, science enthusiasts. I am Decadent Abad, and today we're going to talk about the importance of heat and temperature and why it's more important than a hot espresso in the morning. Now, heat is the captain of maritime comfortness, turning the cold sea into a warm embrace and turning each wave into a pure nautical comfort. Now, temperature, well, that's just a thermometer telling us whether we're in tropical waters or polar current. Now, setting sail without knowing the temperature is just like setting sail without a compass. In the vast ocean of science, heat and temperature is one of your navigational tools, helping you navigate from point A to point B. Once again, I am Decadent Abad for Heat and Temperature.
Good day, cadets! We're diving in the fascinating world of equilibrium using the timeless playground favorite, the seesaw. Think of a seesaw as a perfect example of balance and equilibrium. When both sides are equal or level, they are in static equilibrium. The torque is on the either end balance each other out, just like the teeter-totter sitting perfectly still. This has been James Relacion for Equilibrium.
Good day, cadets! So today, let's talk all about the measurement and conversion of units. Being a seafarer, it is very crucial for us to know about measurement and conversion of units because it ensures accurate navigation, safety operation, in compliance with international maritime regulation. Precise measurement of distance, speed, and quantities like fuel and cargo helps maintain the safety of the vessel and its crew. Additionally, in adherence to standardized unit facilitates effective communication with other vessels, ports, and maritime authorities, thus contributing to overall safety of the maritime industry. This is Decadent Christopher John Maglasang for measurement and conversion of units.
It's a common misconception among us that forces and motions are just simply concepts in physics, but it's actually more than that. Forces and motion can be seen in our daily lives. Say, for example, the simple movement of my hand is already an example of motion, because motion is just a synonymous term for movement. On the other hand, force is simply the push or pull acted upon an object as an attribute to movement. Say, for example, if I turn this bottle upside down, the water is pulled downwards. If I turn it upside down again, the water is pulled downwards. That is due to a force we call gravity, which acts upon, well, all of us. This has been Emmanuel Jaboneta for Forces and Motion.
5, 4, 3, 2, 1. Hey there, science enthusiasts. I am Decadent Abad, and today we're talking about the importance of maritime.